Here we have a question that asks us to evaluate the integral of 3 tangent squared of x dx, and this problem may arise in the section on trigonometric integrals, so a lot of us would think that this problem would involve the intricate steps of trigonometric integrals, but in fact it's a relatively easy problem. Let's step back from calculus for a moment and just remember one of the classic identities from pre-calculus. We recall that the sine squared of x plus the cosine squared of x is equal to 1. And what we're going to do is transform this identity into one that involves tangent squared of x. So to do that, we will divide each of the 3 terms by the same quantity, and we're going to do cosine squared of x. And we'll see in a moment why this is a convenient choice. Now, sine squared over cosine squared, we probably all recall that sine over cosine is tangent, but since these are squared, then we would actually have tangent squared. So tangent squared of x plus, well, this will just be 1 because cosine squared divided by cosine squared, any quantity divided by itself is just 1. And then on the other side, we recall that 1 over cosine was the secant, but since this is squared, we'll end up with the secant squared of x. Now, this identity involves the tangent squared of x, which is part of our integral, but what we're going to do is actually subtract 1 from both sides of this identity, and then we can see that the tangent squared of x is equal to the secant squared of x minus 1. So where we have this tangent squared of x in our original problem, we're going to substitute it with the secant squared of x minus 1. So our problem will look like the following. We'll have the integral of 3, and then again, instead of tangent squared of x, we'll put in secant squared of x minus 1 dx. Now, let's factor out the 3 to the outside of the integral. This leaves us with a pretty simple integral, secant squared of x minus 1. We're just going to integrate term by term. Now, many of us recall when we first learned calculus, maybe it was in a Calculus 2 course, or the end of a Calculus 1 course, but you might have learned that the integral of the secant squared of u is equal to the tangent of u. So this term right here, when we go to integrate it, we're going to have the tangent of x. In this case, our variable is x, not u. And then the second term, 1, that's very easy to integrate with respect to x. That just becomes x. And then you add your constant of integration, and you are done with the problem. This becomes the answer.